Hello Internet, my name is Waffle and I'm a maker at Discovery Place, and today we're going to be learning about electricity. I'm going to have one or two demonstrations to show you, and then I'm going to have two activities for you to do at home. The first type of electricity today we're going to talk about is static electricity, where charge builds up on something and then is released all at once. This is something similar to if you shuffle your feet across a carpet and then you reach out and touch a door handle and you get an electric shock. Have you ever seen a $100 bill that has our founding father, Benjamin Franklin, on it? He's famous for experiments in electricity. See, he noticed that lightning and static electricity were both attracted to metal, and so he did an experiment in 1752 where he flew a kite with a key in it in a thunderstorm. And when lightning struck the key, he was able to detect a charge on the ground and proved that lightning is in fact electricity. Now, I have a generator here called a Graaff Generator, and what this does is this creates a lot of static electricity. It has a belt that drags electrons from the bottom and kind of deposit it on the top, and then it will spark from the top of the generator to this grounding rod. And the reason it keeps sparking is because as long as the belt is running, it's going to keep depositing more charge onto this. Now, if you look very closely, you can actually see that the grounding rod is moving back and forth because it actually gets attracted to the Graaff generator until it sparks and gets pushed away. And then once it dissipates its charge, it does that over and over again. So this is one of the reasons why styrofoam particles, when they get charged, can be very hard to get off of you, because an imbalance in charges can actually create an attractive force. Now, the electrons in the generator want to spread out. This is actually why they will spark to nearby objects just to get away from each other. If I put my hand on the generator, the electrons will spread out throughout my body and cause my hair to stand up. If I touch metal to discharge myself, my hair will go back down, but if I take my hand back off, it'll go up again and go down and up and so forth. All right. Now, just as we saw as the grounding rod could be attracted to the Graaff generator, if we connect the rod to the Graaff generator itself so it's also charged, we can use this to attract an aluminum can. Now, this is our first activity that you can do at home. You might not have a Graaff generator at home, but have you ever rubbed your hair with a balloon and it got all staticky? It's because you're actually scraping electrons from your hair onto the balloon. And once you've charged up your balloon, you can actually use it to move the aluminum can. Before we move on to the next activity, I'd like to show you a quick clip of a musical Tesla coil at Discovery Place. The video quality isn't the best, but by changing the current and voltage in the Tesla coil, we can get the sparks to make different sounds, and stringing these different sounds together makes music. The next type of electricity we'll be talking about is current electricity. As opposed to static electricity, where the charge builds up and then gets discharged all at once, current electricity is a constant flow of electrons in a circle, called a circuit. So this would be something like with a battery, where you have electrons flow from one end through maybe a light or something else, and then back through the top. For our next activity, we're going to make a small electric motor using a battery, some washers, a small wire, and some strong magnets. First, we'll connect the magnets to the bottom of the battery, and then we will place some washers on top. You can use a little bit of tape to keep the washers in place if they aren't sticking via the magnet. You want to bend your wire so it has a little hook at the top, and at the bottom it forms a loop but doesn't touch itself. When you rest the top of the wire on the battery, the loop should contact the magnets below. Let go of the wire and watch it start to turn around the battery. If you reverse the direction of the magnets, you'll notice that the wire spins the other direction. What is happening in this case is that the flowing currents create magnetic fields. And the magnetic field produced by the electricity running through a wire pushes against the magnetic field created by the magnets and causes the wire to move. If you flip the magnets around, this reverses the direction of the magnetic field and thus reverses the direction that the wire is being pushed. A small safety note, don't leave the wire running on the battery for a long time because the wire will start to heat up as electricity is flowing through it. I would like to thank everyone for watching, and I hope you learned something new about the different types of electricity. If you try any of these activities at home, we'd love for you to share your results with us, and as always, we encourage your questions and comments in the section below. My name is Waffle, and we look forward to seeing you next time.